Hi everyone, so these are my instructions of how to do B7.2 in the Isaac chemistry problems. Now this is known as a back titration, and in the experiments you took 2.5 grams of the carbonate and you reacted it with hydrochloric acid, 100 centimetres cubed, and that was the concentration 1.00 mole per decimetre cubed. And that was an excess, so there was too much acid. So the carbonate, whatever it was, and we don't know what the carbonate was, reacted with the acid and turned into a salt and carbon dioxide and water. But some of the acid was left over. So what did you do with this? Well, you transferred it into a standard flask, 250 centimetre cube standard flask. Then you took little bits of this, pipette full, a 25 centimetre cube pipette of it, called an aliquot, and that was then titrated using sodium hydroxide. And that's the equation for the titration. So the philosophy is that if we know how much sodium hydroxide was needed to neutralise the excess acid, we know how much acid was left over after the reaction with the carbonate, and if we know how much acid we added in the first place and how much was left over, the difference is what reacted with the carbonate, and therefore we can use mole calculations to find out the identity of the carbonate. So let's do it. So here's the problem as we see it in Isaac chemistry. And we're asked to calculate the values that should go into the titration results table. And as you can see, we're always giving the answer to 4 significant figures for all the burette readings or the titras. And remember, titra just means the volume that was added from the burette. And then in part E, we had to notice that one of the results was anomalous, and from that find the number of moles of sodium hydroxide. So here we are doing the first parts of the calculation, and I have laid out the titration results in the way that I think they should be laid out in a formal titration. And here you can see the answer to part A, part B, part C and part D. Do notice that in titrations that we always record to 2 decimal places, where the second decimal place is always a 0 or a 5. Now the concordant titra, if you look along here, 24.10, 24.10, 24.45, so that's anomalous, 24.10, so our concordant titra, and the answer to part E is 24.10. Then in part F, they want us to work out the amount of sodium hydroxide. So in other words, I'm going to use the formula, the concentration times the volume, to find the number of moles. The concentration of the sodium hydroxide is 2.50 multiplied by the volume from the titration gives me this number of moles. Do be aware that the question wants you to put that into 3 significant figures, which of course comes out as 6.03 times 10 to the minus 3 moles. So in Isaac physics we see we have to find out the amount of hydrochloric acids, and therefore the initial amount that we added to the carbonate and the amount that was left over after the reaction. Now to solve part G and find the number of moles of HCl in each aliquot, in each 25 centimetre cubed, we need to think about the equation for the titration. And here we see a 1-to-1 ratio between sodium hydroxide and hydrochloric acid. So the number of moles of hydrochloric acid equals the moles of sodium hydroxide, and therefore I just copied the number from the previous part into this answer position. Now, in part H, they asked the question, how many moles of HCl did you start with? So go right back to the beginning part of the question, and you should find that you have the concentration and the volume of HCl at 1.00 moles per decimetre cubed, 100 centimetres cubed. Therefore, you had 0.100 moles of hydrochloric acid at the beginning. Then in part I, they want to know how much HCl was remaining after the reaction with the carbonate. In other words, the stuff that went on to be used in the titration. Well, earlier on in part G, you told me that there were this many moles in 25 centimetres cubed of hydrochloric acid. So in 250 centimetres cubed, it would be 10 times that much, giving me an answer like this. Once again, do notice that that should be written in the answer to 3 significant figures, although I'm leaving it on my calculator in 4 significant figures, and later on you'll see why that matters. So now we need to find out how much hydrochloric acid reacted with the carbonate. I think part J is the hardest bit of the titration, because you have to really think what you actually did. You started off with this many moles of HCl, and you added the carbonate that reacted with some of the HCl, and this much was left over. We know that from the titration. So if this much was left over, and you started with this much, how much actually reacted with the carbonate? Well, it must be the difference between the two numbers. And the answer to part J is 3.98 times 10 to the minus 2 moles. Once again, do notice that if you did not remember to not to round off the number earlier, you're going to end up with 3.97. That's why we always keep the full number on your calculator. If you're not sure how to use standard form in Isaac Chemistry, I can help you with that. You need the little up signal in order to put the superscript for the minus 2. So we're very near the end now. We know the number of moles of carbonates, and from that we can work out the relative molecular mass of the carbonate, and from that we should be able to identify the metal ion in the carbonate. The good news is that we're nearly done. So here we're trying to find in part K the number of moles of carbonate, and for this we needed to remember the equation for the reaction between hydrochloric acid and the carbonate, and it was a 1:2 mole ratio. Therefore the moles of carbonate are the number of moles of hydrochloric acid divided by 2, gives me 1.99 times 10 to the minus 2 moles. And then in part L they want us to find out the relative molecular mass of the carbonate. Well, MR is mass divided by moles, which is a rearranged form of the equation that you've been using since year 10, I suppose. Gives me an MR of 126. So finally, to find out who this blessed carbonate is, part K, something carbonate. Who is it? We know that its MR is 126. Carbon weighs 12. Oxygen weighs 16, and there's 3 of them. So together they weigh 60. Take 60 away from the 126, and you have a relative atomic mass for this guy of 66. Now here you have to get out your periodic table and search up who has an approximate relative atomic mass of 66. I can't give any clues beyond that, because frankly, if you can't read a periodic table, how did you get onto my course in the first place? You may have trouble putting the identity of the cation, sorry, not carbocation, just cation, putting the identity of the cation into Isaac Chemistry, and there is a knack to using that little functionality at the end, and I can happily show you how that's done later on.